Hello, everyone, and welcome back to week 4 of AI with Cup of Java. Today, we're going to be learning more about classification algorithms. So, as we mentioned last week, classification is a type of supervised learning where we want to determine which class an example belongs to. And we talked about this last week to do with Instagram and, for example, not predicting, but determining whether something is an inappropriate comment or an appropriate comment. And you're classifying that into, is it an appropriate comment, yes or no? And those are our two classifications. So here a little bit more in depth. Binary classification is when you're splitting something into two classes. So here the example is determining if an image shows a coyote or a wolf. And a multi-class classification is determining what class it fits into when there are more than two classes. So for example, in this example, it's saying determine what kind of cancer the image depicts. So these graphs do a really beautiful job of describing this. As you can see here, there are only two clusters in this binary classification, but with multi-class, you can have 3 or as many as you want. So, what are classifiers? A classifier is a model that assigns the correct class or label to an example. So, what do we need to do? We need to identify what the data set type is, what the classes will be, what the features that we care about, and then we need to obtain a training set. So, let's kind of go over this with the example that we talked about on the last slide, which is determine if an image shows a wolf or a coyote. So our first step is to determine what data type this is. So as it says here in the text, we have images. So that is our data type. We have a data set of images. The next is to determine what classes are we classifying. So we have two classes. So this is going to be binary classification. This is a coyote or a wolf. And then we want to talk about features. So we have to determine what features we think are important to classify. Some that I'm just coming up on the spot with. Fur hair and ear size and eye color could be our 3 features that we want to look at when classifying these two animals. And then we need a training set. And this training set is of data that is already labeled. So we already have pre-labeled data that says this is an image of a coyote, this is an image of a wolf, so that our model can learn on this. Sorry, we're having some technology problems. We're just going to give this a minute. Okay, we're back. And here we have the classification approach. So the first thing you're going to do is to train the classifier on the training set. So again, going back to what the training set is, this is when your data is already pre-labeled. So we have images that are said to be coyotes and images that are said to be wolves. From here, you go into feature selection and then training. And then we want to predict what we want to measure our training classifier and the training error. So we want to play with that. And then we want to evaluate, okay, how did this classifier perform? What is the error and how can we fix that? And from here, you're going to modify and retrain the classifier to be more and more accurate. And from there, you go to the test set. And once you're done with your training set, and once you think your classifier performed as well as it could, you go to your test set and you run this model on your test set. And then you evaluate and you see what the actual error is. What could this model do when it has never seen images before and they're unlabeled? How does it classify them? So today we're going to be learning specifically about the 2 most common classification algorithms. One of them is called decision trees and the other is KNN, or K nearest neighbor. So what is a decision tree? A decision tree makes decisions by splitting up the training set based on specific features. So when trying to decide how to classify an example, a series of yes or no questions is asked. So this image on the left is a really good example. So we have our root node here, which is the first question. This is the main question that's being asked. Not the main question, but the first question. So up here it says the root node. And again, you say the series of yes or no questions. So first we're asking, is it alive? If no, then it's not, then it's not in our classifier. But if yes, then we ask, does it fly? And then from no, it goes to, does it have a trunk? And then from no, it says, you're gonna go into what animal it is. So here, and then these two are called the leaf nodes, and the leaf nodes are, okay, what, so right here you have a dog and an elephant, so our leaf nodes are the dog and the elephant. So is the rule, it is a rule-based classifier. So at each step we follow a specific rule to make a decision. So here we are implementing the rules in order for the model to make a decision. So kind of a brief, very quick overview of what decision trees does. So first you're going to look at the training data set and you're going to select the feature that gives you the best split. For example, when talking about wolves and coyotes, the color of the fur is probably not the best way to go. I know I said that before, but that was just an example. Because the color of the fur is so similar, it's not going to give you a good split of what is a wolf and what is a coyote. So you want to choose a feature that would really distinguish between a wolf and a coyote. Then you're going to create a new node in the tree based on the split. So again, going back to the previous slide, these are nodes. So the questions are the nodes. So is it alive? Does it fly? Does it have a trunk? Those are all nodes. So then you're going to separate your training data based on the split. So ideally, your splits are going to want to give you you want as little splits between you want as little splits that you can have in order to get your answer or get your correct prediction. So once you separate for each group, you repeat until all examples of the group have the same class. So all images of coyotes are in the coyote class and all images of wolf are in the wolf class. Or the group already has less than some number of examples, or the tree has already been split a certain number of times. And for B and C, this is determined by you. So you can determine what number of examples you want, or what the base level of examples is, or how many splits is the max. You can determine that. And then if met, you create a child node to represent the class. So here, the child nodes are the elephant and the dog. So I'm going to go over a quick demo, but instead of me doing it myself, I'm going to show you exactly what we're going to do, and I want you guys to try this. So here we're going to go over the scikit-learn and scikit library. And the scikit library, or called sklearn in Python, if you're familiar, is a very common library used with machine learning. So I would recommend pulling up a Google Colab. So Google Colab is a type of Jupyter notebook, and it's very, very useful. And I would recommend running some of these blocks of code that I am showing you right now. So if you are interested, I would highly recommend you pause the video here and you read and you copy down exactly this block of code. So the iris dataset, which is the dataset that we want to be working with, is already in the scikit-learn library, and we want to predict what species of iris flower this is. So in order to load in the iris dataset, because you don't know what dataset you're working with, the program doesn't know what dataset it's working with, you're going to want to write in this code, and then iris equals load _ iris. And then here it's saying to print the iris dataset, but this is just to give you an example of an idea of what the iris dataset looks like. And this is exactly what it looks like. And that's not useful, right? You can't analyze that. There's nothing to see there. So what you can do here is to print out what exactly is in the dataset. So here we are printing, okay, what can we print of the iris data set that is useful to us. So here it's printing the target names, the feature names, the target, and the first 10 columns of data, right? So here you can see it's printing first the target names, and the target names here are Septosa, versicolor, virginica, and then the feature names are sepal length, sepal width, petal length, and petal width. So what did we discuss about features? Features are what you are determining to be the most important to categorize these two, or to classify these two classes. So here we think it's important that we measure sepal length, sepal width, and petal width in order to classify these iris species. So what you're doing here now, by printing iris.data, here you're making sure okay, so here when you're splitting up what we're going to do is to split up the training and test sets. This means that you're going to split up the training and the testing set into what can be used in order to train the data, so it's labeled, and what is going to be used to test the data, so it's unlabeled. So first I would copy this into your Google Colab. And as you can see here, the testing size is 0.25, so our training size is 3/4 of the data. So now that we've split our decision tree, we want to train our decision tree. So here is exactly what you need to do. And this max depth is how far it's going to go. So I would mess around with this if you want a better, or where you want to see how changing the depth affects how it's classified. And then to visualize this in a tree, you can visualize it using this code right here. And then again, to test your decision tree, you can print it like this. And you can figure out, okay, using this code over here, you can figure out the accuracy of your model. So this tutorial shows you really well how to train and test the classifier. So if you want it in a very concrete and concise way, this is all that you need to do in order to train and test the classifier. So as you can see, it's very, very, very easy. I would highly recommend pausing the video and copying this into your Google Colab and running it to see just exactly how easy it can be. And I would put print statements as you go in order to figure out what each step is doing if you don't quite understand it. And you can also pause the video anytime to look at any of the steps that I have just made. I would also highly recommend searching up how to plot certain how to plot scatter plots if you don't know already in Python, because that is going to be a very, very useful thing. We also went over it last class when we were talking about graphs in Python, and I did a live demo of that. So if you don't remember, I would highly recommend going back to that video. Okay, so now that we've gone over decision trees, we're not going to go over KNN, or K to the nearest neighbor. And what this classification algorithm does, is that it relies on the assumption that similar examples should be classified the same. So examples are usually represented as points on a graph, and the similarities depend on the distance between one point and others on the graph, or the classes on the graph. So this picture on the left is a really good example. So you have your two classes here, class A and class B, and you have a point, and this is a new example that you want to classify. So we want to see, okay, what point is closest to this point on the graph right now in order to classify it. So as we can see here, the point closest is a class A point. So we are going to classify this new example as a class A point. Okay. So what do we do with with our kth nearest neighbors algorithm? The first thing we do is we choose the features we care about and we quantify them. For example, if one of our features is darkness, we quantify it so that 0 is lightest and 1 is darkest. Going back to our wolf and coyote example, if we're talking about the color of fur and we want to go from white to black, the whitest fur could be 0 and the blackest fur could be 10. The next is to plot the label training set on a graph based on the selected features. This is why in our last video we were so heavily emphasizing graphing and plotting in Python, because it's quite important, especially in machine learning and in classification. So then you're going to plot an unseen example on the graph based on its new features, and then compute the distance from the new example to all the training examples and see which class it fits in best. So here is an extension of nearest neighbors. So if there's a tie between one class and another class, the classification is based off the k minus 1 nearest example. So we're going to quickly go over a demo just as we did before. Again, I'm not going to physically do it, but I'm going to run through it just as I am doing it. And I would highly recommend you pausing the video anytime you would like to copy down the code into your Google Colab and run it just so that you can see how it works. So here we're going to really quickly go over the KNN algorithm using scikit-learn, which again is the very common Python library. So you're going to do similar to how you did last time with the decision trees, but you're going to use these import statements, and you're going to import our data set, and then we're going to load in the digits data set. And then this code right here is just plotting what your data set looks like. So that's going to be here. And basically each number is associated with a grayscale value. And as you can see here, this is now plotting 0. So here we're basically extracting the values, and then over here in this code over here, we're splitting it into a training and testing size. Last time we trained with 3/4 of the data. Now we're training with 90% of the data. So you can see how you need to change your size of your training set and the size of your testing set according to which data set you have. And this is an important thing to learn. And this is a big part of machine learning, is learning to figure out, okay, what size do I need to test with, or what features do I need to use? Coding it is pretty standard all the way through, but these are the kind of the important parts. And what classes am I using? So that's just a quick overview. So here we are going to be importing the classifier and training the classifier and computing the score. And as you can see, very quickly you can come to see that this code is all very short. But the big point is, okay, again, what are the features, and what is my data set, and what is my training size, and how many values am I using to train? So what you're going to see here after you print all of this, you're going to see your score, and this is your accuracy score. And I would play around with how many values you use in your training and testing split, and play around with the training size. And this will give you a pretty good example of exactly what KNN is. So now that we've gone through both the demos, I want you to do this. And I want you to go through what we have learned and find your own data set on Kaggle, or on any other platform. But Kaggle is a really, really good way to do this. You do have to make your own account, but it's very simple. And then I would like you to figure out what features you want to use, what classes you want, what algorithm you're going to use based on the pros and cons and what we discussed in previous slides. And then I want you to graph it using the skills that we learned last week. and then train and test your data. And once you've done all of this, you have gotten a very, very good base example of what AI is in Python and how to implement it. So thank you all again for coming to this week's video, and thank you again for your interest in artificial intelligence. And I hope you guys had a great lesson, and we hope to see you all next week again. Thank you guys. Bye.